This is Cambridge IGCSE, paper 2, multiple choice extended for chemistry, specimen paper for examination from 2023. Question number 1. A gaseous substance is slowly cooled and the temperature recorded every second. The results are shown on the graph. At which point is the substance a solid? Now, remember, this is a cooling graph. So, essentially, substances at high temperatures are presented as a gaseous state, and then during the cooling process, gas is converted to liquid, and then liquid is then converted to solid. Right, and then the ones that are horizontal are actually simultaneous states, which is gas and liquid at the same time. Okay, as this is the condensation part, that's the boiling point. And then for this other horizontal line that represents the melting point, or should I say freezing point, where liquid and solid are present simultaneously. So in accordance to the question, solid state is present at D. Right, moving on to the next question. 2. A gas is released at point Q in the apparatus shown. Which gas changes the color of the damp universal indicator paper most quickly? Now, in order for the gas here, okay, to actually affect the universal indicator paper, the gas will have to diffuse across the tube and reach the universal indicator paper. So it means that we are trying to find diffusion and which gas actually diffuse the fastest. Okay, with the fastest rate of diffusion. So what kind of gas has the highest rate of diffusion? That will be the ones with lighter mass, okay, specifically relative molecular mass. All right, so the most likely answer, although seems like D, hydrogen gas, but this is about a universal indicator paper. This is affected by the nature of the gas, whether it's acidic or basic. So neutral gas will not have an effect. So this is a trap. All right, hydrogen gas will not change the color despite it diffuses the fastest. So it's either of the above 3. Ammonia is basic. Carbon dioxide is slightly like weakly acidic. And then chlorine is more of an acidic gas. So the most likely answer is actually A, ammonia. Right, it has the lightest mass and then it's a basic gas. Right. So the answer is A. Moving on to the next question. Which statement describes the bonding in sodium chloride? So sodium chloride is an ionic compound. So essentially, you are trying to identify which of the following is a description for ionic compounds. So A, a shared pair of electrons between 2 atoms leading to a noble gas configuration. Now, ionic compounds do not share electrons. B, a strong force of attraction between oppositely charged ions. That's in fact the definition of ionic bonding, which is present in ionic compounds. All right, so the answer is B. We can have a look at C also. A strong force of attraction between 2 molecules. Whenever you see the word molecules, it's covalent. All right, not ionic. And then D, a weak force of attraction between oppositely charged ions. Now, ionic bonding is strong. Okay, it's not weak at all. Right, so the answer is indeed B. Moving on to question number 4. The lead in a pencil is made of a mixture of graphite and clay. When the percentage of graphite is increased, the pencil moves across the paper more easily. Which statement explains this observation? Now, so you see that the pencil moves across the paper more easily, which means that graphite is acting as a lubricant. All right, so making writing easier. In fact, that's the property of graphite. That's why we use them in pencils. So the answer is C. Moving on to the next question. 5. Which statement about metals is not correct? So A, they conduct electricity because delocalized electrons can move throughout the metal. That is, in fact, what is found in a piece of metal, where the positive metal ions are surrounded by these freely moving delocalized electrons, which circulates within the metallic structure. All right, so they are freely moving. Okay, so A is correct. So based on the question, it's not what we want. B, they consist of layers of atoms that can slide over each other. That is, in fact, correct, because that's why metals are malleable. Right? C, they have a giant lattice of oppositely charged ions in a sea of delocalized electrons. Now, this is wrong. Right? Metals are positive cations. Okay, there are no negative ions, or should I say anions present in the metallic structure. So C is wrong. That's the answer that we want. So the answer for number 5 is C. Let's check at D. They have a giant lattice of positive ions in a sea of delocalized electrons. That is absolutely correct for metals. Right? So the answer is indeed C. Moving on to question number 6. Aqueous iron 3 sulfate and aqueous sodium hydroxide react to give a precipitate of iron 3 hydroxide and a solution of sodium sulfate. What is the balance symbol equation for this reaction? Now, let's look at the formula first for each of the chemical compounds present. So iron 3 sulfate is Fe2SO4 which means all of these are correct, right? Have a look at them. All of these are correct. And then for sodium hydroxide, the formula is NaOH. So all of them are correct. And then for iron 3 hydroxide, it will be FeOH3. So the formula of all 4 options are correct. And then lastly, the sodium sulfate formula is Na2SO4. So this is correct for all of them. So you can see that this question is trying to test you on your coefficients, on your balancing. So you just need to check whether both sides have equal number of atoms. So let's look at A. Well, you can see that here on the left-hand side, there's 2 iron, but on the right-hand side, there's only 1. So you don't have to check others anymore. This is wrong. Look at B. Same issue here. 2 ions on the left, but only 1 ion on the right. So this is also wrong, not balanced at all. So it's either C or D. If you look at iron, they do have the same numbers on both sides for both options. So we have to focus on another element, which is you can focus on the sodium, which makes it easier for you to see. So if you look closely, there are 6 sodium ions on the left. So on the right-hand side, it should only have 6, not 12. So D is wrong. The answer is C. All right, let's look at question number 7. which information is needed to calculate the relative atomic mass of an element? So let's look at each of the options. A, the total number of protons and neutrons in the most abundant isotope. That's not exactly accurate because we are considering all of the isotopes when we actually give you the mass number. Right? So not the most abundant, but all of them depending on their relative abundance. B, the nucleon numbers and the total number of isotopes. Not exactly accurate. Right, it's not too specific in terms of it didn't mention about relative abundance. Right. So C, the mass number and the abundance of each of its isotopes. There's actually a better answer than D, right? Because you're considering the mass and also you're considering the abundance of each of the isotopes. So the answer is C. That's why, for example, I give you an example. Chlorine, if you look at the periodic table, the mass number is 35.5. Right. Why is it having a decimal? Because it's considering the relative abundance of chlorine 37 and also chlorine 35, which are two isotopes that are present in real life. So essentially, they get an average, and then they get the number 35.5 due to the mass number and also the abundance. So the answer is C. All right. So for D, the atomic number and the abundance of each of its isotopes is nothing to do with atomic number when you're considering the masses. All right, let's move on to number 8. The equation for the reaction between sodium carbonate and excess dilute hydrochloric acid is shown when 26.5 grams of sodium carbonate reacts with excess dilute hydrochloric acid. What is the maximum volume of carbon dioxide produced? So let's try to focus the question, pinpoint the main points. It's about sodium carbonate and also the carbon dioxide form. All right, so given in the equation, the theoretical mole ratio between sodium carbonate and also carbon dioxide is a 1-to-1 ratio. Right, and then you are trying to find out what happens if you only use 26.5 grams of sodium carbonate. So you need to convert mass of sodium carbonate to number of moles. So let's do that. How can we do that? Actually, just divide the mass by the molar mass of sodium carbonate. So you will need your periodic table for that, right? So if you check your periodic table, the mass numbers of these elements are 23, 12, and 16. So all you need to do is add them all together. So 2 sodium will have a mass of 46, and then 1 carbon is 12, 1 oxygen is 16, so 3 of them makes 48. So add them all together, it should be 106. Right, so that's the molar mass of sodium carbonate. Let's divide it and then find out the number of moles. Use your calculator. Give me a second, I'm trying to type this in my calculator. So divided by 106, you get a quarter, or should I say 0.25 moles. So 0.25 is the amount that you're using. So based on the theoretical mole ratio, it is actually giving you similarly a quarter of carbon dioxide. Let me be more specific, a quarter mole of carbon dioxide. So this question is about volume. So we need to convert a quarter mole to volume. So how can we do that? Actually, just multiply by 24. So volume of carbon dioxide form is taking 0.25 multiplied by 24, which is the molar volume, then you get 6. Right, because 1 mole of gas occupies 24 dm cubed, so a quarter of that will only occupy 6. So the answer is A. All right, moving on to question number 9. A volumetric pipette is used to measure 25 cubic centimeters of 2.0 mole per cubic decimeters aqueous sodium hydroxide into a conical flask. A burette is filled with dilute sulfuric acid. The equation for the reaction is shown. The reaction requires 50.0 cubic centimeters of dilute sulfuric acid to reach the end point. What is the concentration of the dilute sulfuric acid in mole per cubic decimeters? Right, let's try to figure that out. Similarly, based on the question, this is about a neutralization reaction, and then we are given from the equation about the theoretical mole ratio, which is a 2:1 ratio for sodium hydroxide and sulfuric acid. So in this question, the clues given to you are the fact that you are using this specific amount and concentration of sodium hydroxide. So let's convert this to number of moles first. How can you find the number of moles of this particular chemical substance? By taking the volume multiplied by the concentration. So it's 25.0 multiplied by 2.0. But because these two are of a different unit, right, so you need to convert 25.0 cm cubed to dm cubed first. So you do that by dividing that by 1,000. Hence, you should get, let's see, let me just use calculator to speed this up slightly, which is 25 divided by 1,000 multiplied by 2. So you get 0.05 mole. And then based on the ratio given in the equation, it's 2:1 ratio. So in real life, we are using 0.05. So the number of moles of sulfuric acid used is actually half of that amount, which is 0.025. Right? So now we have the number of moles of sulfuric acid, which is 0.025 moles. And then the volume used is 50.0 cm cubed, which in other words, it is actually how many decimeter cube? It's now 0.05 dm cubed. So let's take these two values and then figure out the concentration, which is taking 0.025 divided by 0.05. You should be able to get 0.5 mole per dm cubed. So the answer should be A. Right? If you have extra time, whenever there's calculation, please double check your answers. Okay, we don't want to be careless in our working. So the answer is indeed A. All right, just be careful in your calculations and then double check if you have extra time. If you find out that you spend too much time on calculations, just skip to the next one first and then come back later. All right, moving on to question number 10. The diagram shows a circuit used to electrolyze aqueous copper 2 sulfate. Which arrows indicate the movement of the copper ions in the electrolyte and of the electrons in the external circuit? So it's a two-part question. One is about the ion movements in the electrolyte, and the other one is on the electrons in the external circuit. So copper ions are actually attracted, since they are positively charged, they are actually attracted to the negative terminal, right? Or should I say it is attracted to the cathode. So the direction will be to And then electrons in the external circuit, we know that electrons flow from the negative terminal to the positive terminal in the electrical circuit. So the direction should be 3. Right, it's heading towards the positive terminal. So the answer should be C. All right, moving on to question 11. Which row shows the waste products released from the exhaust of a vehicle powered using a hydrogen-oxygen fuel cell? Now, hydrogen-oxygen fuel cell is just this reaction. Hydrogen reacts with oxygen, gives you, well, energy, and also water. Okay, and nothing else. So there's no carbon dioxide. Right, no carbon dioxide whatsoever. So we can eliminate A and also C as the answers. And then there's absolutely no oxides of nitrogen and only water. So the answer is D. Pretty straightforward. All right, moving on to the next question. Which diagram is a correctly labeled reaction pathway diagram for an endothermic reaction? The keyword here is endothermic. Okay, in an endothermic reaction, reactants have a lower amount of energy compared to the products. Right, that's why they suck energy in. Right, they suck heat energy in. Okay, they need to get boosted. Remember, endothermic reactions are about reactants getting boosted to become products as a net. Okay, a net result of that. So C and D are obviously off because you see that reactants have a higher energy than products. These are exothermic reactions. So either A or B. So the next part is about your labels, right? The activation energy. Now think about it for a second. Do the products need activation or the reactants need activation? It's the reactants, right? Products just, well, products. They don't need activation at all. So this is wrong. It's actually A. Right, see the curve? Reactants need to get boosted, need to get activated to become products. And then the overall energy change, okay, is you see that reactants need to get boosted to become products. So the answer is A. All right, moving on to the next question. 13. Which changes are physical changes? Physical changes refer to changes that only change states, for example, solid to liquid to gas, right? And there is no change in the formula of the chemical substance. Okay, so the formula shouldn't change. So let's see. 1, melting of ice to form water. Absolutely, that is, in fact, a physical change. 2, burning hydrogen to form water. You see, it's changing from H2 to H2O. That's actually a chemical change. 3, adding sodium to water. When you add metals to water, it forms usually forms a hydroxide, right? And also hydrogen gas, usually. That's the general equation. So that's off. So it will be 1 and 4. In fact, boiling water to form steam is a physical change reaction. Right, from ice, if you look at this equation, so ice to form water, right, it's a physical change. There's no change in the chemical formula, only the states. And then boiling water to form steam. So steam is still hydrogen, sorry, it's still water, H2O, but it's just in its gaseous form. So the answer is 1 and 4. All right, moving on to the next question. 14. The diagram shows an experiment to measure the rate of a chemical equation. Which change decreases the rate of reaction? The keyword is decreases the rate of reaction. Well, A, adding water to the flask. Yep, because that actually dilutes the solution. In other words, it's decreasing the concentration, and we know decreasing concentration leads to a decrease in the rate of reaction. So the answer should be A. But let's check B, C, and D anyway. B, heating the flask during the reaction. Heating increases the rate instead. C, using more concentrated acid. That actually increases the rate also. And then D, using powdered metal, that increases surface area, like exposed surface area to the other reactant. So that actually increases rate as well. So the answer is indeed A for question 14. Moving on to the next question. Which role describes the effect of increasing concentration and increasing pressure on the collisions between reacting particles? Okay, two parts of this question. One is on increasing temperature, the other one is on increasing concentration. What does it mean by increasing concentration? Now, when you say concentration, it usually refers to aqueous solutions. And it refers to the amount of solutes over volume ratio. So increasing, well, concentration usually refers to more solutes in a particular volume. So you can think of a particular space have more particles, more solute particles. So as a result of that, right, these particles are always colliding. So they collide more, right? So more collision per second. But do they gain more energy per se? No, right? They shouldn't get more energy. They just collide more, but the total, well, the energy possessed by each particle will still remain, well, pretty much constant. Okay, the overall, what do you call it? Overall energy of the particles don't exactly increase, right? The profiles don't change anymore because you're not providing external energy. So what about increasing temperature? Now, we know that increasing temperature does boost the particles to move faster due to, well, you're providing energy to them. They gain energy and then they move faster. So that actually leads to more collision per second as well. Right, despite the number of particles remain constant, but still they move faster, so means they will collide more. So the answer for this question is B. Right, so concentration does not exactly increase the term more collisions with sufficient energy, and then temperature does increase both. Right, so the answer for 15 is B. Right, moving on to the next question. 16. Methanol is prepared by the reversible reaction shown. The forward reaction is exothermic. Which condition produces the highest equilibrium yield of methanol? In order to produce more yield of methanol, you will need to drive the equilibrium to the forward reaction. So because the forward reaction is an exothermic reaction, in order to, well, favor the forward reaction, you will have to cool the mixture, cool the reactor mixture, or should I say cool the system, a better word for that. And then in terms of pressure, pressure affects the equilibrium position if there are different number of moles of gaseous particles on both sides. So in total, you see that altogether on the left-hand side, there are 3 gaseous particles, and then on the right, there's only 1. So in order to drive this forward, you will have to increase the pressure. So the answer for this is C. Right, a lower temperature and a higher pressure will drive the reaction, will cause the equilibrium to favor the forward reaction. Moving on to the next question, 17. When chlorine gas dissolves in water, a reaction occurs. Which row of the table identifies the oxidation number of chlorine in the chlorine-containing species? Well, let's check one by one. First of all, chlorine molecule is a neutral, uncharged molecule, which means that the oxidation number should be 0. Second, hydrogen chloride. Now, hydrogen ions usually exhibit a +1 charge, +1 oxidation number. And then, so this chloride should have a -1 charge. -1 as its oxidation number. So the answer, we need to figure out the last one anyway. So this thing, HClO, what is the oxidation number of chlorine in this case? Now, hydrogen usually exhibits +1, and oxygen usually exhibits -2 due to its position at group 6. So in this case, in order to make a neutral particle, if we were to make an equation out of this, it will look like this. So the sum of the oxidation number should lead to 0 because this is an uncharged. But overall net charge is 0. So you need to do some calculations of that. And you will get this particular chlorine atom is exhibiting a +1 as its oxidation number. So the answer is D, or 17. All right, moving on to question 18. 4 different solutions, J, K, L, and M, are tested with universal indicator. Which solutions are acidic? Now, acidic should be red, orange, right? Remember, universal indicator is known as the rainbow solution. The first few colors of the rainbow, red, orange, well, those are acidic. And then in the middle, it's neutral. And at the end, it's basic. So just remember, universal indicator is what we call a rainbow solution. Okay, so the answer is B. Red and orange are belonging to the acidic part. All right, that's the answer for question 18. Let's look at question 19. Which solution has the lowest pH? When a solution has very low pH, it means that it is extremely acidic. So, A, ammonia solution is alkali. B, ethanoic acid. Now, this is a weak acid. Remember, it's an organic acid. So it should be a weak acid that will not be having the lowest pH. C, hydrochloric acid, which is a strong acid. So the most likely answer is C. Lithium hydroxide is alkali. So it will not have the lowest pH. The answer is indeed C. Now, question 20. Magnesium, calcium, strontium, and barium are group 2 elements. Group 2 elements follow the same trends in reactivity as group 1 elements. Which statements about group 2 elements are correct? Let's write that down first, the list down, so that we can see that the trend here. So magnesium, calcium, if I'm not mistaken, strontium, the short form is ST, and BA. That real quick. Oh, SR, my bad. Right? So let's see. We know that at group 1 elements, like among group 1 elements, the reactivity increases down the group. So calcium reacts faster than magnesium with water. That is correct because calcium is more reactive than magnesium due to its lower position in the reactivity series. 2, barium reacts less vigorously than magnesium with dilute acid. So barium belongs at the bottom, like at a lower position than magnesium. So barium should have a higher reactivity, so it should be more vigorous. So 2 is wrong. 3, strontium oxidizes in air more slowly than barium. That is correct. Okay, so strontium is less reactive than barium, so it oxidizes more slowly. So the best answer is C, 1 and 3. All right, so remember the reactivity series, you can draw it vertically, or if you want to, you can actually do it horizontally, which is like this. So you just see which element is the weakest and which element is the strongest in terms of reactivity. Okay, which one suits you better, you just use that. Now, question 21. Chlorine, bromine, and iodine are elements in group 7 of the periodic table. Which statement about these elements is correct? Similarly, let's draw a line showing these 3 elements. Now, down group 7, the reactivity decreases actually. It's the opposite of group, like metals. Okay, other than that, let's see. The color gets lighter? No. Iodine is, well, reddish brown, super dark. Bromine is, what do you call it? Actually depends, right? It depends, like, is it in aqua solution? Is it in solid state? Is it in, what do you call it? An organic solvent. So their color actually gets darker, generally. All right, so let me rephrase that. Iodine actually is purplish black if we're talking about solid. Okay, sometimes it does exhibit like reddish brown. So regardless, we're not concerned about that. We're just concerned about the intensity of the color. So it does get darker down the series. So A is wrong. B, the density decreases down the group. No, the density actually increases down the group. C, they are all gases at room temperature and pressure. No. Okay, because the melting point and boiling point increases down the group. So essentially, it's like gas, and then proceed to liquid, and then proceed to solid. So the answer is D. They are all non-metals. Right, these are group 7 elements. So they are non-metals. Moving on to question 22. Which row describes the properties of a typical transition element? So you can give examples like copper or iron. Right. So let's see. Melting point is indeed high for transition elements. And then variable oxidation number, yes, there is a special feature for transition elements. So the best answer out of this is actually B. Right. Because transition elements can also act as a catalyst. Right. So the answer is B. High melting point, variable oxidation number. For example, copper, there's copper 1, and also there's copper 2. And then iron, there's iron 2 and iron 3. Right. And then they act as catalysts. For example, in Haber process, iron is used as a catalyst. Right. So the answer is B. Moving on to question 23. Which statement about the noble gases is correct? Noble gases are diatomic molecules. That is wrong. They are monoatomic gases, which means they occur as like single. B, noble gases are reactive gases. That is the exact opposite of noble gases. They are extremely unreactive. C, noble gases have full outer electron shells. That is correct. Right, that's why they are unreactive and also the solo. Okay, they occur by they occur singly. 1. Okay, so the answer is C, and they're actually found on the right hand side of the periodic table. Okay, moving on to question 24. What is a property of all metals? So you have options: conduct electricity, hard, low melting point, and also reacts with water. Now, the best answer out of this is A, right? We know that all metals conduct electricity, although the strength depends, right? The conductivity scale depends. Hard, not exactly, right? Because remember, alkali metals like group 1 metals are soft in nature, like sodium. Right? If you have done it in the lab, you cut it, it's pretty soft, just like water. Okay, and then low melting point, well, transition elements have high melting point, transition metals have high melting point, so no. And reacts with water, not all metals react with water actually, right? Copper doesn't exactly dissolve in water, right? So it's A. Conducts electricity is the best answer out of this. Right? So 25. Which statement explains why aluminium is used in the manufacture of aircraft? Because it has a low density. So the answer is B for question 25. Right. You see, even other options are possible, but you have to base on the context. Why are we using it in aircraft? Because it's light, easier to, well, let the airplane, well, in terms of lifting, it's easier. Right. So the answer is B. Okay, and then aluminium is not exactly a good insulator, and then it is easy to recycle. Depends, context dependent, right? It is recyclable, but depends. Okay, not exactly related to the manufacture of aircraft. All right, moving on to the next question, 26. The section of the reactivity series shown includes a newly discovered metal, symbol X. Oh, it's located between the reactive metals and also like unreactive elements. The only oxide of X has the formula XO. Which equation shows a reaction which occurs? Now, remember, in the reactivity series, the ones on top are the strong ones, which means reactive. The ones at the bottom are weak, or should I say less reactive. Okay, so essentially, X is somewhere in between. And we see X is more reactive than hydrogen and copper, which means that it is able to displace copper out from its salt solution. So the best answer out of this question, hold up, there's actually another clue of this. It has the formula XO for the oxide. Oxides, the oxidation number of oxide is -2, which means that X has an oxidation number of +2. Which means that in this question, if you see X has +1, that's actually wrong. So it's either A, C, or D. You know what? Let's check one by one because there's too many words here. A, copper solid displaces X out of the solution. That's wrong because copper is weaker. Not possible. So it's either C or D. Then this is wrong also because two solids react with each other. Unless you're talking about displacement in terms of the burning, like the furnace thing. But X is weaker, you see? It's weaker, it's less reactive than iron. So it shouldn't be possible to steal the oxygen from iron. So C is also wrong. So the best answer is D. In fact, that's correct, right? Because you see, X is stronger than hydrogen. So, okay, let me use a more accurate term. It's more reactive than hydrogen. So you see, X is very capable of stealing the chloride from the hydrogen. See, it is able to displace hydrogen out from the hydrogen chloride, or should I say hydrochloric acid, and form the chloride of X. So the answer is D in this question. All right, moving on to question 27. Which metal compound produces a gas that turns lime water milky when it is heated with a Bunsen burner? Now, whenever you see the word gas that turns lime water milky, you should think of carbon dioxide. Now, what metal compounds, when heated, produces carbon dioxide? There will be carbonates. So the answer is A. You don't have to look at others. And in fact, B, C, and D don't have carbon. So it shouldn't be possible for them to produce carbon dioxide because carbon is absent. So the answer is A. Moving on to 28. Which statement about the extraction of iron in a blast furnace is correct? Calcium oxide reacts with basic impurities? No. This is basic. Calcium oxide, metal oxides are basic. They shouldn't be able to react with basic impurities. B, carbon is burned to provide heat. That's why we put carbon, the coke, right? Coke, which is actually carbon. It is a source of fuel. It provides heat in a blast furnace. So the answer is B. Right? C, iron 3 oxide is reduced to iron by carbon dioxide. No, that's actually by carbon, coke. Or carbon monoxide. Because carbon dioxide is already stable, it won't be able to take any more oxygen from iron 3 oxides. So the raw materials are bauxite, limestone, and coke. No, not bauxite. Bauxite is aluminium, like ore of aluminium oxide. So it should be hematite. So the answer is B. Moving on to question 29, an experiment to investigate the effect of painting iron is shown. The experiment is left for 7 days. What happens to the water level in test tubes X and Y? Wow, this is actually, whenever you see iron, whenever you see air, whenever you see water, it's a recipe for disaster, rusting. Right, iron and air and water, it's for rusting. So remember, paint protects the iron from rusting. So pure iron will corrode and form rust as a result of exposure to air, oxygen in the air, and also water. So because the air and water actively reacts with the iron, which means that the water level will rise for X, and then test tube Y, no reaction, so it shouldn't be changing. The answer should be donkey for D for donkey for 29. Moving on to question 30. Bauxite contains aluminum oxide. Aluminium is extracted from aluminum oxide by electrolysis. Which statement is the reason for why cryolite is added to the electrolytic cell used to extract aluminum? Cryolite decreases the rate at which aluminum ions are discharged. No, it does not decrease the rates. And then, like, it's pretty weird, right? Why are we adding something that disrupts our purpose, which is to get aluminum ions get discharged? B, cryolite lowers the melting point of the electrolyte mixture. Not exactly wrong. Although I won't encourage my students to write this answer in paper 4. But let's see C and D first. Cryolite prevents the carbon anodes from burning away. No, it doesn't do that. Okay, carbon anodes are, well, they will be burnt away anyway. So that's why you need to replace them from time to time. And then lastly, cryolite removes impurities from the bauxite. No, it does not do that at all. It's not that magical. So the best answer out of this question is B, although I won't encourage my students to write this in paper 4. Because the real purpose of cryolite is actually to lower the operating temperature. Right, it acts as a solvent. Like if you talk about model answers for paper 4, it acts as a solvent. It improves electrical conductivity and lowers the operating temperature. If we check back on previous mark scheme from previous years, these 3 are the best answers recommended by Cambridge Board. So it's better for you to write these answers instead of this. Okay, but we don't have a better option, so let's just pick B anyway. Moving on to the next question, 31. Which statement is correct? Atmospheric carbon dioxide is not a cause of climate change. Well, carbon dioxide, if it's too much in the air, in the atmosphere, it's causing, well, it's a greenhouse gas, so it leads to greenhouse effect. And then greenhouse effect can lead to global warming. And essentially, if it's too much, it can lead to climate change. So A is wrong. B, atmospheric carbon monoxide is produced by complete combustion of carbon-containing fuels. That's wrong. It should be incomplete combustion. That's why I produce this, like incomplete, half-baked product. Right. Ideally, it should produce carbon dioxide. Each carbon should get 2 oxygen, but now you are only producing a half-baked product. Why? Because it's incomplete combustion. C, burning natural gas decrease the level of carbon dioxide in the atmosphere. No, it's literally the source of carbon dioxide in the atmosphere. So it should be increasing. So the best answer is D. Let's see. Decomposition of vegetation causes an increase in atmospheric methane. Yes, that is true. Right, decomposition produces methane. Okay, so the answer for 31 is donkey. D for donkey. Now, 32. A plastic combusts to form sulfur dioxide and hydrogen chloride. How could both gases be removed from the air? The clue here is these 2 gases are actually acidic in nature. Which means that how can we remove acidic gases? Use a base. So the best answer out of this is B. Pass the gases over solid damp calcium oxide, which is a base. Others don't do much in terms of removing these 2 gases. Right. Moving on to question 33. Which equation represents photosynthesis? So photosynthesis is the process of carbon dioxide and water getting converted by plants or algae to form glucose and oxygen gas. So A and B are wrong because the reactants and products are, well, at the wrong position. So it's either C or D. So the answer is D. If you look at C, the coefficients are wrong. 3 carbon, and then this forms 6 carbons. That's not possible. So it should be D. 6 carbons form 6 carbons on the right. Right, so the answer is D. Now, question 34. Which statement defines structural isomers? So structural isomers are compounds with the same molecular formula but different structural formula. So you just have to see which is the answer. So the answer should be C. They are compounds with the same molecular formula, but different structural formula. So the answer is C. Now, question 35. Petroleum is a mixture of different hydrocarbons. Which process is used to separate the petroleum into groups of similar hydrocarbons? So this is by fractional distillation. The answer is C. Right? Because essentially petroleum is a mixture. And then all of these hydrocarbons have different boiling points. So you need to do fractional distillation in order to get the separation. All right, moving on to question 36. Which equation represents a reaction of methane? So based on just your first glance onto the question options, right? You are trying to react alkenes with halogens. Remember, alkenes are generally unreactive. The only way for it to be able to react with halogens is to use, well, UV radiation, UV light. Right? So this is a halogenic displacement reaction. Sorry, not halogen displacement. My bad, my bad. A little bit mixed up because I see the word halogen. It should be substitution. My bad. Okay, it's only maximally it's only able to substitute. So what's the best answer out of this four? Should be just A. Right. This chlorine molecule, one of it replaces, substitutes one of the hydrogen atoms, leading to the formation of this particular molecule. And then the remaining hydrogen reacts with the remaining chlorine to form hydrogen chloride. So the answer is A for 36. All right, so my bad for saying the wrong word just now. This is substitution, not displacement. Displacement is a different reaction. Okay, I'm so used to halogens displacement reaction. So yeah, my bad for that. Let's double check the answer. Yeah, it is A. Methane react with chlorine gas, forms chloromethane and also hydrogen chloride gas. Yeah, the answer is A. Moving on to question 37. Ethanol can be produced by fermentation or by the catalytic addition of steam to ethene. Which role shows an advantage and a disadvantage for each process? Well, fermentation is a batch process because the microbes that assist in the fermentation will die, right? Will die, and then you have to replace them. So it must be a batch process. That's actually a disadvantage. It doesn't make the best, like, efficiency, as you need to replace them often. So there's more of a disadvantage. So A is pretty much off. So the advantage of fermentation is that the raw materials are renewable. Right, it's renewable. So fermentation is not exactly fast, right? It's not exactly fast. So from my perspective, the best answer should be C. Let's check that further. Wait, hold up just a minute. I don't think it's C. Renewable, yes. These two are correct as well because you see, fermentation is a biological process. These microbes, right, they are not just producing ethanol for you. Essentially, it's their own metabolism. They may produce other byproducts. It's whatever they want. Right. So essentially, your product will not just be ethanol. Maybe there are other organic compounds that are produced from the metabolism of these microbes. So we have to check for this one also. Catalytic addition of steam to ethene. The advantage is fast. Okay, so C is wrong because catalytic addition is a fast process. Okay, so it's not exactly slow. So the best answer for 37 is D. And yeah, the disadvantage of steam to ethene, like for catalytic addition, is finite raw materials. Right? Because it requires like high heat process, which means that you need to burn more fossil fuels, etc. And also the source, right? Ethene, which is an organic molecule. So we have, well, not exactly a lot of that from the first place. So the best answer out of 37 is D. Right? Renewable for fermentation, but the disadvantage is that it's a batch process, it's slow, it's impure, and then for catalytic addition of steam to ethene, the advantage is that it's fast, and then the disadvantage is more of the raw materials are limited. So the best answer is D. Moving on to question 38, part of the structure of a polymer is shown. Which monomer is used to make this polymer? Well, all you need to do is taking the repeating unit, copy and paste this, essentially, and cut off the terminals and make the center a double bond. That's the monomer structure. Right, so copy the repeating part and change the center to a double bond and then cut off the terminals. So the best answer is B. Right, should be B. Yeah, it is B. Okay, that's for question 38. Move on to question 39. 5 steps in an acid-base titration is shown. What is the correct order of these steps to complete an acid-base titration? Well, essentially, if you remember, titration, there are two parts. Essentially, the setup of the acid and setup of the alkali / base. So group them together. In this case, the titration is having the acid in the burette, and then the alkali is in the conical flask. And then what do we add in the conical flask? An indicator. All right, so let's group them together. 4 and 5 should be together because you see, read and record the initial volume of acid in the burette, and then final volume of acid in the burette. So 4, 5, and 1 are one group in terms of the acid. Right, see, acid, acid, acid. Then 2 and 3 belong to the same group, which is the base, the indicator, and also the alkali. So just check for keywords. You don't have to read everything if you don't have time, okay? So we just need to know for acids, what comes first. It should be read and record the initial volume first, followed by slowly adding the acid from a burette into a conical flask until the indicator becomes colorless. And then followed by read and record the final volume. So the sequence should be 415 for acid, and we see that the conical flask is ready in step 1. So it should be setting up the alkali first, followed by the acid. So the best answer is B. So let's recheck everything. Start with 3 first. Use a volumetric pipette to add a fixed volume of alkali to a conical flask. And then you add thymolphthalein indicator. And then you set up a burette with acid. And then record the initial volume first, followed by adding the acid, and then finally record the final volume. So the answer is B. Right, moving on to question 40, the last question. A student does paper chromatography on a mixture of amino acids. The student sprays the dried chromatogram with a locating agent. What is the function of the locating agent? To form colored spots with the amino acids. This is pretty straightforward. Okay, it's to locate. Right, to locate the amino acids by form colored spots with them. So that's all for this specimen paper. Okay, so this is an impromptu explanation and analysis and discussion of the paper. So I apologize for some of the mistakes that I made during this discussion, but I still hope that it will be able to assist you in your exams. Okay, all the best in the exams, and then that's all. And then thank you for watching, and I'll see you in the next one. Thank you.